Hello dear students, welcome to this session. In this session, we are going to learn an important graph algorithm called Prim's algorithm, which is used to find a minimum spanning tree or simply MST. So before we understand the algorithm, first understand what a minimum spanning tree actually means. Imagine there are several cities that need to be connected using roads or cables. So our goal is to connect all the cities while spending the least amount of money. A spanning tree is a set of edges that connects every vertex in the graph without forming any cycle. Among all the possible spanning trees, the one with the minimum total weight is called the minimum spanning tree. So MST has three important properties. It connects all the vertices. It contains exactly n-1 edges where n is the number of vertices, and it does not contain any cycle. So minimum spanning trees are widely used in real life applications such as designing computer networks, telephone networks, road construction, railway planning, electrical wiring and water pipeline systems where we want the minimum installation cost. So now let us see the procedure of greedy algorithm. So the step-by-step procedure is, we can start with any vertex in the graph. It does not matter which one we choose. Next, we include that vertex in the minimum spanning tree. Now we look at all the edges connected to the selected vertices and choose the edge with the smallest weight that connects to a new unvisited vertex. After selecting that minimum edge, we add both the edge and the new vertex into our tree. So again we repeat the same process every time. We look at all the possible edges connecting the existing tree to the remaining vertices and choose the edge with the minimum weight. One important thing to remember is that we should never create a cycle. If adding an edge forms a cycle, we simply ignore that edge and choose another minimum edge. This process continues until all the vertices become the part of the minimum spanning tree. So now let us see the step-by-step execution of Prim's algorithm for this graph. So in this graph, we are having the vertices V1 from V8. So we have to create minimum spanning tree, which means all the vertices should be connected and there should not be any cycles. So we begin with the vertex V1. So we begin with the vertex V1. At this point, V1 have two possible edges. So V1 to V2 is 8 and V1 to V8 is 16. Here the minimum weight is 8. So select the vertex V2. So include the edge, and now in our minimum spanning tree there are two vertices V1 and V2. And next we will select the next edge. So from V2 to V3 is 16 and V2 to V8 is 22. Here the minimum edge is 16. So connect V3. So include the edge 16. So now there are three vertices V1, V2, V3 are in our minimum spanning tree. Next, from V3 we have to select the minimum edge. So there are V3 to V4 is 14, V3 to V6 is 8, V3 to V9 is 4. So the minimum cost edge is 4. So select the vertices, select the vertex V9. Okay. In next, from V9 we are having the vertex 14, 12. So which is greater. So we will move on to the, we will backtrack to the V3, which is the minimum having weight of V3 to V6 is 8. So select that edge and include the vertex V6 into the minimum spanning tree. So next, from V6 we are having the minimum weight edges 4. So V6 to V7. So next include the vertex V7 so that the tree cannot form any cycle. So in the next step, after including the edge, V7. Then we will select the V8, which is having the minimum weight 2. So now there are vertices V1, V2, V3, V9, V4, V6, V7 and V8 are in our minimum spanning tree. So the next minimum cost edges V3 to V4, which has the minimum weight of 14 compared to remaining unconnected edges. So include V4 to the minimum spanning tree. So the next remaining unconnected vertex is V5. So the edge cost 18 is smaller compared to 20 and 28. So that edge 18 is included. So now all the vertices in the graph have been connected and there is no cycles have been formed. So this is our final minimum spanning tree. So if we add the all the weight of the edges, this will lead to the cost of this minimum spanning tree. So thank you students.